Hi, I'm Jodie from EdGenie and I'm going to be going through the October 21 Pure 1 Edexcel A-Level Maths paper. I'm going to be telling you exactly what I'm doing and exactly why I'm doing it, and I'm also going to have a little look at the examiner reports to see what other students commonly got wrong. So question 1, we've been given a function which is in terms of a and we've got some x's. Given that x minus 1 is a factor, find the value of the constant a. You must make your method clear. And it's 3 marks, so it's not a massive question, but it is going to take a little bit of working out. So if x minus 1 is a factor, we know that when x equals 1, f of 1 must equal 0. Okay, because if it's a factor, that means we're not going to have any remainders. So let's substitute that in, and we're going to have a times 1 cubed plus 10 times 1 squared minus 3a times 1, take away 4, and that's going to equal 0. Simplify that. A times 1 cubed is a. 10 times 1 squared is 10. Minus 3a times 1, so that's just minus 3a. And then we've got minus 4. Simplify this again. So a minus 3a is going to be minus 2a. 10 minus 4 is going to be 6. Now we can take away 6 from both sides. Divide both sides by -2, and we are left with a equals 3. So the examiner report said that most students did really well in this question, but some students tried to use long division, which did lead to some errors because it's quite a lot trickier than just substituting in. Question 2, given that f of x equals x squared minus 4x plus 5, express in this form, so we're completing the square, where a and b are integers that we need to find. So let's have a go at that. So remember, we halve the coefficient of x, so half of -4 is -2. So it's going to look like this, x minus 2 all squared. Let's multiply that out to see what we get, because we want to get x squared minus 4x plus 5. X times x is x squared, x times -2 is -2x, and again -2x. -2 times -2 is positive 4. So these two terms simplify to give us that -4x. We have that x squared, but we haven't got this plus 5, we've got plus 4. So to get to plus 5, we need to add 1. Okay, so this is our final answer. Then it says the curve with the equation, so this curve, meets the y-coordinate at point P, and it has a minimum turning point at the point Q. Find the coordinates of P and the coordinates of Q. So I'm just going to do a really quick kind of sketch, just so I can see what we're doing. So it's positive x squared, so we know it's going to be this kind of shape. We also can work out where it's going to cross the y-axis. So when x is 0, can you see how it's going to cross at 5? So it's going to look something like this. That's going to cross at 5. We also know this coordinate because we can get that from where we've completed the square. X is going to be 2 because the smallest number squared is 0. How do I get x minus 2 to be 0? X must equal 2. And when x is 2, you're just left with the 1, so that must be the y value. So actually, looks like we've done it. Find the coordinates of P. So P was the y-axis, so that's going to be 0, 5, because it does say the coordinate, so you want it as a coordinate. And the coordinates of Q, which was our minimum turning point, is going to be 2, 1. The examiner report said that the vast majority of responses were seen fully correct. If you did a graph and you labelled on your graph your coordinates, you did get the marks, even if you didn't write your coordinates afterwards. Question 3, we have a sequence here and it's defined by un plus 1 equals k minus 24 over un, where u1 equals 2. K is an integer. Given that u1 plus 2u2 plus u3 equals 0, show that, and then we've got an equation here. So let's give this a go. If we know that u1 equals 2, then u2 we can figure out by substituting in here. So we're going to do k minus 24 over u1, which was 2. That's going to give us k minus 12. So u3 is going to get a little bit fiddly here. K minus 24 divided by k minus 12. And I'm not going to simplify that yet. I'm just going to leave it as it is. So u1, which is 2, plus 2 lots of u2, which is k minus 12, plus u3, which is k minus 24 over k minus 12, and we know that that equals 0. So let's scroll down and do a little bit of rearranging. I'm going to multiply this out first. So I'm going to get 2 plus 2k minus 24 plus k minus 24 over k minus 12. And it's worth simplifying this again before I multiply everything by k minus 12. So 2 minus 24 is going to be minus 22. 2k plus k is 3k. And then this fraction we're just going to leave as is for the moment. Now I'm going to multiply everything by k minus 12. So I'm going to have these two terms times k minus 12. This fraction, if I times it by k, I'll just put a bracket around there. If I multiply this fraction by k minus 12, I'm going to be left with minus 24. Right, let's multiply this out. 22 times k minus 22 times minus 12 is going to be positive 264. 3k times k is going to be 3k squared. 3k times minus 12 is going to be minus 36k. And we've also got that minus 24. Simplify this. Let's do our k squareds first. Done that term. Then let's do k. So we've got minus 22k minus 36k. So that's going to be minus 58k. So that's that term and that term done. And then we've got 264 minus 24, which is nice. That's 240. And that equals 0. Now, go back up to the question. What did we want? Oh, that's what we wanted. So we're done. Now let's have a go at part B. Find the value of k, giving a reason for your answer. So that straight away is telling me that there's going to be 2 values of k because it's k squared. And 1 is probably going to be, let's read the question. So it says k is an integer. So I'm assuming, I'm not sure yet, that 1's going to be an integer and 1's not going to be an integer. And then I'll give my reason. So let's give it a go. We could try and factorise this. And if you're really quick at factorising and you can see it straight away, then definitely factorise. If you can't see it straight away, then there's nothing wrong with using the quadratic formula, whatever's going to be quicker for you. So let's do k equals, so we're going to do minus b plus or minus the square root. We're going to have b squared. I'm going to put that in a bracket so it squares correctly. Minus 4 times a times c all over 2a. Now you're probably thinking, she could just put that all into her classwork calculator and it would just give the answer straight away. Yeah, we actually in this case could, because it doesn't specify in the question that you need to show every single step. So we could do that. Let's give this a go then. So it's 3 minus 58 and 240. So my two answers are 40 over 3. And my other answer is 6. So yeah, this one's the correct one because that one is not an integer. And I'm just going to make a statement there. I'm just going to say k equals 6 because k is an integer, anything like that. Because k is an integer. There we go. Part C is find the value of u3. So we know u3 is k minus 24 over k minus 12. K is 6. Put that all into the calculator all at once. Don't do like different parts in your calculator and then put it all together because you're just going to waste time. And also that's where people make mistakes. And that's 10. So the examiner report said that this question was a little bit more demanding than the first two, but over 40% of students managed to get all 6 marks. So the errors were that they forgot to simplify the U2, so that caused issues later on because it was a lot more complicated for them. And in part B, they forgot to state that k is an integer, so it must be 6. And part C was answered very well by the people who managed to get part A and part B. Question 4 says we have a curve with an equation f of x equals x squared plus ln of 2x squared minus 4x plus 5 has a single turning point at x equals alpha. So that means that when you differentiate, it will give you 0 at that point. Show that alpha is the solution of the equation, and they've given us an equation. 4 marks, so it might be a little bit fiddly, but let's give it a go. So I'm going to differentiate this. X squared, that's nice and easy, that's just going to be 2x. Now we've got a log here, so remember when we differentiate the log, you differentiate this, which is going to be 4x minus 4, and that is going to be over the original function, so 2x squared minus 4x plus 5, and we know that that is going to equal to 0. So let's do a little bit of rearranging. So I'm going to multiply everything by this denominator, so I will get 2x multiplied by all of that denominator plus 4x minus 4 equals 0. Now let's just simplify that a bit. Multiply this out. Okay, and we've also got our plus 4x minus 4. Simplify this. So collect all the cubes. Collect the squares. Then all the x's, so you can see we've got 14 minus 4. So now have another look at the question and see what format they want it in. Okay, so it looks like if we divide everything by 2, this is going to work out. So divide everything by 2, it's going to be 2x cubed, 4x squared, 7x minus 2. Okay, and that is equal to that. So we've done it. The iterative formula is this is used to find an approximate value for alpha. starting with x1 equals 0.3, we've got a few values to find. So x1 equals 0.3. We want to find x2. We don't care about x3 for some reason. And then we're going to find x4. So on your calculator, what you need to do is program in the 0.3. So type in 0.3 and then you're going to press equals. And that means that the calculator is going to remember that answer. Now, where it says 0.3 or 3 over 10, don't now clear your calculator. What you now want to do is type this in, but instead of where it says X, you're going to use that answer button. So I'm going to write 1 over 7 multiplied by, in a bracket, 2 plus 4 times, and then the ANS button, which says answer, that squared, minus 2 times, again, that ANS answer button, that cubed. Close my brackets, press equals. So the first one, right, I've got a crazy fraction. This actually says 4 decimal places. So press that S to D button and I've got 0.3294. Next one, that's going to be x3, but we don't want that. Press equals again and we have got 0.3398. And that's it, done. So part C, using a suitable interval and a suitable function that should be stated, show that alpha is 0.341 to 3 decimal places. So what you want to do is pick a value just before and just after that value for alpha, and then hopefully there's a sign change, which will mean that the root is going to be between those. So let's try. So this is our function that we're trying to use here. We want to do f of, let's do 0.3405, so just before. We're going to substitute that into here. 2 times 0.3405 to the power of 3 minus 4 times 0.3405 squared plus 7 times 0.3405 minus 2. And I have got a syntax error because I didn't close my bracket on the cubed. Is that why? Yeah. So I have got minus 13056. Doesn't actually matter. All that matters is that it's a negative. So don't clear the calculator, because then you're going to have to write it all out again. Now just change the values to this. And yeah, it's positive, so it's great news. And that keeps going. So there's a few things we need to say here. So the first one is sign change. Second thing we need to say is that this, so our derivative, is continuous. So therefore we know that alpha equals 0.341 to 3 decimal places. So the examiner report for this question said that A and B was done quite well, but part C, some people didn't realise that you needed to look for the sign change, and then we're using the iteration more and more to try and get closer to the root. But that method was not accepted as it's not a proof of the location of the root. A few chose to substitute into an inappropriate functions, such as f of x, so that didn't work either. It was very common, however, for the final mark to be lost in this part because there was no mention that the chosen function was continuous. So this question comes up a lot. Really, really important. You need to make sure you say that it is continuous. So question 5, it says, in this question, you should show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. So what that means is that you can't just plug it all into the calculator. You have to show the quadratic formula, you have to factorize, you have to show every single step in order to get the marks. So a company made a profit of £20,000 in its first year of trading. So that is year 1. A model for future trading predicts that the yearly profit will increase by 8% each year, so that the yearly profits will form a geometric sequence. According to the model, show that the profit for year 3 will be this, and it's only 1 mark. And the reason it's only 1 mark is because you covered this back in GCSE. So we are starting with £20,000. If we are increasing by 8% each year, that means that every year you're going to have 108% of what you had the year before. So as a decimal, that's 1.08. Because we're starting at year 1, so year 1 we have 20,000. Year 2, we don't care about that. Year 3 should be this, but actually that's only 2 years after we started. So we're actually going to put to the power of 2. Put this into our calculator. And we get exactly what we wanted, 23,328. Find the first year where the yearly profit will exceed 65,000. So we're going to use this formula. And just be careful here. So I'm going to put n minus 1. You could call this m, for example, and then at the end just take away 1 from it, whatever you prefer, whichever is easiest for you. And we want that to be larger than 65,000. So the first thing I'm going to do is divide both sides by 20,000. $65,000 divided by 20,000 is going to be 13/4. Then I'm going to take logs because I'm trying to find out the power. So taking logs will be the best way. Remember, when you take logs, you have to take them off both sides. And when we have a power, that then can be rewritten like this. So let's divide both sides by ln 1.08. So n minus 1, put this whole thing into our calculator. Oh, I didn't close my bracket. That's given me 15.31. That keeps going. So if I then add 1 to that, that's going to be 16.31, blah, 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 blah. But that means 16 years won't be enough to exceed it. And we're not having partial years, we want full years. So that means that n must be 17. So part C, we want to find the total profit for the first 20 years of trading, giving your answer to the nearest £1,000. So for this one, we want our sum of 20 years. Because each year it's giving us a profit. We want the total after 20 years. And this formula that we need is actually in our formula booklet. So make sure you're really familiar with this so that you can quickly find things when you need it. We are looking for geometric. Here we are, and this one here is the one we need. So it is A. Let's substitute in our values. So A is our first. Let's substitute in our values. So A is our starting amount, which was 20,000. R, which is 1.08. N, which is 20. Again, R, 1.08. Put that into our calculator. It's going to give us 915,239. So this is going to be to the nearest thousand, let's put approximately, £915,000. So the examiner report said that about 35% of candidates got full marks, but that still means like 65% of people didn't get full marks. And the most common error was forgetting about the n in part 2, which is B, and not doing the n minus 1. So that meant a lot of people had an answer of 16 instead of having an answer of 17. Okay, we've got a 5-mark vector question. First one, so we've been given A to B and we've been given B to C. We want to find A to C. So we want to find this one here. But because we've been given this one and we've been given this one, all we need to do is add those two vectors and it will give us A to C. So we can write that A to C equals A to B plus B to C. So if we look at the I components, we have got -3 plus 1. For the J, we have got -4 plus 1. And for K, we have got -5 plus 4. Let's simplify this. -3 plus 1 is -2. -4 plus 1 is -3. And for K, -5 plus 4 is -1. So I'm just going to put -K for that one. And that's the answer. Show that cos ABC is 9/10. So we want ABC. So this angle here is what we're trying to find. So, we're trying to show. To do that, we need to use the cosine rule, but we also need to know our different lengths. So let me remind you of the cosine rule. So we're going to have A squared equals B squared plus C squared minus 2BC cos A. Okay? Or in this case, because the angle's B, you might want to rewrite it like this if this makes more sense to you. But either way is fine. B squared is going to be this length here. So we want to find out AC squared. A squared is going to be this length. So that's BC squared. C squared is this length. So that's AB squared. Minus 2 times BC times AB times cos B. So let's have a go at finding these different values. So AC is going to be the square root of, it's over here, -2 squared. Of course, if we're squaring a negative, the negative doesn't matter, so I'm just going to put 2 squared plus 3 squared plus 1 squared. And that, if I put that into my calculator, 2 squared plus 3 squared plus 1 squared is square root of 14. Let's do the same for BC. So it's going to be square root of 1 squared plus 1 squared plus 4 squared. That is going to be 3 root 2, or should I leave that as a square root of 18? It's probably a bit easier, isn't it? Yeah, that's easier. Just because we're going to square it in a minute, so I think if I just leave it as square root 18, that's going to make more sense. And the last one that we need is AB. So minus 3 squared, or just 3 squared, 4 squared, 5 squared. Put that into a calculator. And that is the square root of 50. Okay, we're nearly there. Substitute these values into here. So AC squared, so square root of 14 squared, it's going to be 14. BC squared, so that's 18. AB squared, which is 50, minus 2 times, and these ones aren't squared, so we are going to have a square root. Root 50 cos B. Now, when we put this into our calculator, you want to put as many parts in as possible, because if you do a little bit here and a little bit there and then put them together, you're more likely to make mistakes. So I'm going to put all of this into my calculator. Then I'm going to do all of this into my calculator and then times that by cos B. So 14 equals 18 plus 50. We don't need a calculator for that. 2 times square root of 18 times square root of 50. Oh, and that's given me 60. How nice. So 60 cos B. Let's rearrange. So let's add 60 cos B to both sides. And take away 14. Divide by 60. Oh, it's 9 over 10, which, fingers crossed, yeah, we got it. So the examiner report says that 40% of candidates got full marks on this question. It was done quite well, but students who lost marks, it was mainly small errors here and there. Circle questions are my absolute favourite, so we're going to like this one. So they've given us an equation of a circle, and they've asked us to find the coordinates of the centre and the exact radius. I'm just going to underline that so I remember. Giving your answer as a simplified surd. Okay. So to find the coordinate of the centre and the radius, we kind of do the two questions together. We need to complete the square twice. Let me show you how we do it. So before I actually do any maths, I just rearrange it so that I've got the x's together, then I've got the y's together, and then the constant. This just makes it a little bit easier for me when I'm completing the square. So let's complete the square for these two terms, and we are going to get x minus 5, so it's half of negative 10, all squared. I want to get the constant to 0, so don't worry about the 11, we'll deal with that later. Negative 5 squared is 25, so I'm going to take away 25, so that this gives me just x squared minus 10x. Then, same thing with the y terms. 2 squared is 4, so if I take away 4, that gives me back to y squared plus 4y, and then I've got plus 11. Right, rearrange. I don't mean rearrange at all, I mean simplify. Minus 25, minus 4, plus 11, that gives us minus 18, and then we can put that on the other side, so it's positive 18. So straight away we can see what our centre is. So part I. And that's going to be when x is 5 and y is -2. So it's whatever the values here are, just the sign swapped. Then our radius is going to be the square root of 18. So it always equals, so all of this will equal to our radius squared. So our radius squared equals 18. So our radius is going to be the square root of 18. And you might be thinking, why is she not doing positive and negative? It's a radius. So we can't have negative a radius because then it just wouldn't exist. It's like if we were measuring like a wall, you can't have a negative value there. It has to be positive. So we know it's going to be the square root of 18. Square root of 18 is 9 times 2. So that's 3 root 2. Right, part B. Let's give us a bit more space. It's 5 marks. I think it's going to be a little bit fiddly, this one. The line L has this equation. K is a constant. Given that L is a tangent to C, find the possible values of K, giving your answers as simplified surds. So let me just show you what this looks like. We have got a circle. And we've got a line which equals y equals 3x plus k, so it's positive gradients, it's something like that, or something like that. Because can you see how those lines could both be 3x plus k, depending what k is, because they've got the same gradient. So we need to find these two values. So there's going to be 2 different values for k. So we're going to have to do simultaneous equations. Let's have a look. Is it going to be easier? So we've got y equals 3x plus k. Is it going to be easier to substitute in here? Or is it going to be easier to substitute in here? It's up to you really, isn't it? What do we think? It honestly doesn't matter. It's up to you. I think either one is going to be just as difficult. I'm going to 50-50. Let's put it into this one. So x squared plus y squared. But remember, y is 3x plus k. This is why it's a lot of marks, because it's going to be a bit fiddly, isn't it? And then, sorry, it's not plus, it's minus 10x. Then it's going to be plus 4 lots of y. Plus 11 equals 0. Yeah, did I get that equation right? Yeah. Right, let's give it a go. X squared. Multiplying out this, we're going to have 9x squared, because 3x times 3x is 9x squared. 3x times k, so I'm going to put 3kx. K times 3x is again 3kx. K times k is k squared. Minus 10x. Plus 4 times 3x is 12x. 4 times k is 4k. Plus 11 equals 0. Now let's simplify this. So we've got x squared plus 9x squared, which is 10x squared. I'm just going to put a little tick so I know that I've done those terms. We have got 3kx plus 3kx. So there's going to be 6kx. Done. Done. Minus 10x plus 12x. So that's going to be 2x. Done and done. Then we have got k squared, 4k, and 11. Okay? Now, the next thing we know is, because it's a tangent, so it's touching at one point, we know that b squared minus 4ac is equal to 0. So this is our discriminant. And just to make it a bit clearer for us, I'm going to write a is 10, b, so it's these two terms here, is going to be 6k plus 2, and c is going to be k squared plus 4k plus 11. So it's going to be a bit fiddly. There's a lot of spaces to make mistakes here. B squared minus 4 times A times C. Multiply this out. 36k squared plus 12k plus another 12k plus 4. Minus 4 times 10 is minus 40. So minus 40k squared. Minus 40 times 4k is going to be minus 160k. Minus 40 times 11 is going to be 440. Yeah. Simplify it. 36k squared minus 40k squared. So minus 4k squared. Done. Done. 12k. Let's use a calculator so we don't go wrong. 12 plus 12 minus 160 is a minus 136k. Done, done, done. And 4 minus 440 is minus 436. Was this a show that question? No, just find. Okay, let's see. Can these two terms be divided by 4? Yeah, the first one can. Yes. Let's divide everything by negative 4. So 136 is going to be 34. 436 is now going to be 109. And the reason we're allowed to just divide it by negative 4 is because it's equal to 0. If it wasn't equal to 0, you wouldn't be allowed to do it. Now I'm just going to check if there's anything at the start of the question. No, so it doesn't say I can't use my calculator. So I'm actually, instead of using the quadratic formula, I'm just going to put it straight into my calculator. So you go to Menu, Equations and Functions, a polynomial, and it's squared, 134, 109. So we have got minus 17 plus 6 root 5, or minus 17 minus 6 root 5. So the examiner report says that not many students realise that you were meant to use the discriminant in this part of the question. So a lot of people managed to get to this part here, but they didn't realise that you should use the discriminant to then find the values of k. Question 8 is very worded, but I don't want you to prejudge it and decide that you can't do it already. Who knows, it might actually be quite easy. A scientist is studying the growth of 2 different populations of bacteria. Okay, so we've got 2 different ones. The number of bacteria n in the first population is modelled by this equation, and time is going to be greater than or equal to 0. Obviously, we can't have negative time, where a and k are positive constants and t is the time in hours from the start of the study. I've just underlined positive because sometimes they might say like, here are 2 different values of k, which one must it be? And then it's easy to forget that it should be positive. Given that there were 1,000 bacteria in this population at the start of the study. Okay, so that means when t was 0, n must be 1,000. It took exactly 5 hours from the start of the study for the population to double. So that means when t was 5, n is going to be 2,000. Find a complete equation for this model. So they basically want us to find a and k, don't they? So the first one, you might be able to see already that a is going to be 1,000, but if you can't, don't worry. So we know that n is 1,000 when t is 0. So a times e to the power of 0 times k. This is going to be 0. Remember, anything to the power of 0 is 1. So this is the same as 1000 equals A times 1, but that's just A. Okay, so well done if you could do that in your head, but if you can't, then it doesn't matter. You could write it like this and have a go. Let's find the other value. So when n is 2000, we know A now is 1000, and E is to the power of K multiplied by 5. So let's put 5K. Divide both sides by 1000. So 2 equals E to the power of 5K. Let's take logs of both sides. Remember, when you take logs of an exponential, that cancels out. Scroll down. Divide both sides by 5. And that's going to give us our K. So our completed equation is n equals A, which is 1000, times E to the power of ln 2 over 5, so that's K, multiplied by T. And it's important just to know that if you don't write this, you're going to lose a mark. Because even though you found A and you found K, they're asking for a complete equation. So if you don't do that, you're not going to get that final accuracy mark. Part B, don't know if I have enough space here, might need to start a new page. Hence, so already we're thinking, right, hence, use the answer to the part before. Find the rate of increase in the number of bacteria in this population, exactly 8 hours, just going to write T equals 8, from the start of the day. Give your answer correct to 2 significant figures. Hence, find the rate of increase. So we're going to need to differentiate. So we're actually going to be finding dn, because it's in terms of n equals, divided by dt, because it's in terms of t. Now, it's quite a nice one actually, because it's an exponential, so it looks tricky to differentiate, but it's actually not too bad. It's going to be 1000, that's just a constant, I'm going to keep it like that. Then you differentiate the function inside of the exponential. So that's going to be ln 2 all over 5 times by, and then it's just the exponential. Remember, when you differentiate the exponential, it stays the same. We only multiplied it by ln 2 over 5 because we're doing the chain rule. And we could write that out again, maybe cancel those out. But I'm not going to do that. I'm just going to substitute 8 straight in. So, ln 2 over 5, e to the power of ln 2 over 5 times by 8. Put this whole thing into your calculator. Do not do part by part. Exponential. 2 over 5 times 8, and got 420 point something. We want 2 significant figures. Okay, so this is what I've got, just to show you. So 2 significant figures is just going to be 420. And what are we talking about? That's the bacteria, isn't it? Number of bacteria. Okay, and that's part B. Let's have a go at C. The number of bacteria M in the second population is modelled by this equation, where K has a value found in part A. Where K has the value found in part A. Okay, so it's the same value of K. And T is the time in hours from the start of the study. Given that T hours after the start of the study, the number of bacteria in the 2 different populations is the same. Find the value of T. Sounds confusing. All they're saying, put this equal to this, and they're saying K is the same value. That's all we're doing. So, here, right. So we've got 1,000. E to the power of ln 2 over 5 multiplied by t equals 500 e to the power of, what was it? 1.4 times k times t. Okay, 1.4 times k times t. Find t, but actually I should have used a capital for t, really, shouldn't I? Because they're saying at time capital T. So let's just change those. Right, let's give it a go. What I'm going to do is I'm going to put all of like the constants on one side and then all of the exponential on the other. I think that might make it a bit easier for me. So if I do 1,000 divided by 500 over here, and then over here I'm going to have this. So this can simplify down to 2 equals e to the power of. So when we are dividing, that's the same as taking away the powers. Let me just write this a little bit lower. I need a bit more space. 2 equals e to the power of. So I'm going to have 1.4 times ln 2 over 5t minus this. So 2 equals e to the power of, this is basically like you've got 1.4 lots of this, and then you've got 1 lot of it. So we're left with 0.4 lots of ln 2 over 5t. Take logs of both sides. Then let's rearrange. And then the question said that I was going to have to round it, didn't I? Didn't it? Number 0 is given that there's find the value of t. Oh, so it didn't in this part. So let's see what it is. Put the whole thing into your calculator. 4 times. Oh, that's worked out really nicely. I've got t equals 25 over 2, or I could write that as 12.5. And was it in hours? Yeah, hours. So it's 12.5 hours, isn't it? That question was actually fine, wasn't it? Once we got started, it wasn't too bad. So the examiner report said that the main issues were getting the accuracy mark. And the reason for that was because up here, when we found out our value of k, they put this as a decimal. So then all the way through the question, it meant that the answer wasn't exactly accurate. So when you've got something like this, like ln 2 over 5, unless it tells you to put it to 3 decimal places or something, just make sure you leave it in exact form, because then you're not going to have accuracy errors later on. Question 9, we have some partial fractions, and we also have a binomial expansion, which is 7 marks. So I already know that that's probably going to hurt our brains. So we've got our function. They've told us what form to put this in, where a, b, and c are constants. Find the value of b and the value of c. Show that a equals 0. So this is all, we're going to do this together, and then I'll at the end say bc is this, a is this. So let's write 5x squared plus 38x plus 9 all over. We have got 5x plus 2 all squared, 1 minus 2x, and this is going to be equal to our 3, nearly couldn't say that, 3 fractions in the form that they've given. Okay, so to make it so that they're not fractions, so to kind of get rid of the denominator, we want to multiply both sides of the equation by 5x plus 2 all squared, 1 minus 2x, and that will make it so that then none of them are fractions and it's all going to be very simple for us to solve. So if we multiply the left-hand side by 5x plus 2 squared, 1 minus 2x, we are going to be left with just the numerator. So just that. This fraction here, we are going to be left with a multiplied by 5x plus 2 multiplied by 1 minus 2x. Can you see that? So it's because the squared here from the 5x plus 2 is going to cancel out with that one. So then we're just left with 5x plus 2 and 1 minus 2x. The other two fractions, so for b, we're going to have b times 1 minus 2x. So that's all that's left after we've multiplied by this. And c, we're going to be left with 5x plus 2 squared. Okay. Now, what I'm going to do next is I'm going to substitute x for a half. You might be able to see why, or you might not. That's fine as well. Because if I substitute a half into here, so if I have 1 minus 2 times a half, can you see how that's going to be 0? So that's in this bracket here. If that's 0, it means the a is going to be 0 because a times 0 is gone. The b is also going to be gone, and we're just going to be left with c. So let's have a go at doing that. Left-hand side, substitute in a half, we are going to have 50 times a half squared plus 38 times a half plus 9 equals. So this fraction, this bracket here is going to be 0. So a times by 0 is gone. This bracket here is going to be 0. B times by 0, that's gone. So we've only got this one. So 5 times a half plus 2 all squared. Okay, get out our calculators. So I'm going to put the whole of this left-hand side into my calculator. Do it all at once. There's no need to do it separately. And I've got 81 over 2. Right, now I'm putting this whole thing into my calculator. So 5 times a half plus 2 all squared. And I've got 81 over 4. That's worked out really nicely. Multiplied by c. So can you see how c is going to be 2? If you can't, that's fine. Just put into your calculator 81 divided by 2, all divided by 81 over 4, and you'll get 2. Right, now I wonder if you can see what I'm going to substitute in next before I tell you. I am going to do minus 2 over 5. Can you see why? So if I substitute minus 2 over 5 into this bracket to 5x plus 2, that is going to be 0. So I'm going to have no a, b I will still have, and c is also going to be cancelled out. So it's going to be really great because then I could just find out b next. So substituting that into here, we have 50 times minus 2 over 5 squared. I'm putting that in a bracket just so I know that negative is also squared because that will make a big difference. 38 times minus 2 over 5 plus 9. So that one's going to be 0, that one's going to be 0. So we're just left with b. So we're going to have b times by 1 minus 2 lots minus 2 over 5. Yeah, put this into our calculator. That's 38 times minus 2 over 5 is 9 over 5. On the right hand side, 1 minus 2 times minus 2 over 5. 9 over 5. That worked out well, didn't it? So we can see that B must be 1. Okay, so we've got C, we've got B. Now we want to go back and find A. So for this one, there's no other value now that we can substitute in that's going to kind of leave us with A but take away B and C, unfortunately. So it's up to you what you want to substitute in. I'm going to substitute in 0. I think that's quite a smart choice. 1 could also be a good choice, but I do think 0 is going to be the easiest. So this side of the equation, 0, 0, 9. Here, 5x, that's 0. So we've got A times 2 times 1. So we've got 2A. Here, B times 1. B is 1. 1 times 1 is 1. C is 2. 2 times, that's 0, 2 squared. So 2 squared is 4, times that by 2 is 8. And look, this looks really nice now because 9 equals 2A plus 9. So you can see actually that A must be 0. Take away 9 from both sides. So therefore, A equals 0. And have we fully answered the question? Find the values of B and the value of C and the value of A is 0. Yeah. If it said express this in partial fractions, then you would have to write it all out again in partial fractions to get that final accuracy mark. But because this is actually saying just find the values, I don't have to do that. Although I'm going to have to do it now anyway in the binomial expansion. So let's do the binomial expansion, 7 marks. So hold tight. We are going to have, what was B? It was 1, wasn't it? 1 over, and was that the 5x plus 2? Yeah, 1 over 5x plus 2 all squared. Plus C, which was 2, I think. Was it 1 minus 2x? Let's double check. Oh, I've put C instead of 2. 1 minus 2x. Yeah. And let's just change that. So that is 2. Okay. Another way of writing this would be like this. Okay, so we've just taken the denominator up to the numerator by putting the power to negative. Now what we want to do is, I'm going to do my binomial expansion, but each bracket separately because I don't want it to get really confusing with all these terms everywhere. But in the question, it only wants us to go up to x squared, so that's quite important. And it's going to be simplified fractions to be found. So if there's any kind of crazy numbers going on, I know that something's wrong and I'll need to go back and have another go. Right, formula booklet. Here we are, binomial series, and we are going to be looking at this one here. So have that open on your desk. Hopefully you've printed this out. I'm just going to screenshot this, although to be honest, it's quite easy to remember this one, isn't it? Just so we don't make any mistakes. And so 5x plus 2 is going to be better to write it as 2 plus 5x, just because that's the format that we always like it in, isn't it? And then we want to take out a factor of 2 because we want this number to be 1. So if I take out a factor of 2, I'm going to get this. And that's all to the power of negative 2. So that means that it's 2 to the power of negative 2 times 1 plus 5 over 2x to the power of negative 2. 2 to the power of negative 2 is the same as 1 over 4 because it's 1 over 2 squared, which is 4. and that's going to be multiplied by my whole expansion. So first term's going to be 1 plus n, which is -2. I like to put this in brackets when it's got the negatives, otherwise I find it gets a bit too confusing, times by the x, and we have got 5/2x, plus next term is going to be -2 times -3. So do n minus 1 times, divided by 2 factorial times by x squared. So it's 5/2x all squared. We don't need to do any other terms because remember the question, we're only going up to squared, so don't need to do any more. But we do need to simplify this. Some people will try and multiply out the 1/4 straight away. I really recommend you don't do that. It's just there's too much going on and you're going to make a mistake. Right, 1, easy. Here we're going to have -2 times 5/2. That's just going to be -5 times the x. This one I'm going to put in my calculator. So we've got -2 times -3 all over 2 factorial, which is just 2 because it's 1 times 2, multiplied by 5/2 all squared. So I do the whole thing in one. I don't do little parts. And that gives us positive 75/4. And then don't forget we've also got the x squared. Okay, there are other terms, but we don't care about them. Times that by 1/4. Let's start a new line. 1/4 times 1, that's easy. Minus 5/4 times x plus 75. 75/16 x squared. Sorry, why did I put x squared there? That's x. Okay, and that's done. Now we need to have a look at this one here. So 2 bracket 1 minus 2x, the power of -1. So 2 lots of 1 minus 2x to the power of -1. Luckily, we don't need to take out any factors for that one because it's already 1 there, but we do need to multiply the whole thing by 2. So multiplying this out, we have got 1 plus, and n is -1, times by x, and x is actually -2x. Next one, we're going to have -1 times -2 all over 2 factorial times by -2x all squared. Okay, and that is the end. There are other terms, but we only need to go up to x squared. Again, don't worry about multiplying out the 2 in one go, because actually you probably make a mistake. -1 times -2 is positive 2x. This one, I've still got this in my calculator from the question before, so I'm just going to change the 5/2 to -2. Oh, well, I have to change the n as well, don't I? So that's -1, that's -2. Yeah, and I've got 4. Yeah. Multiply out the 2. Okay, now let's put all the parts together. So this part here plus this part here. A quarter plus 2, let's think, that's going to be 8/4, 9/4. Yeah. 9/4 minus 5/4 plus 4 is 11/4x, and then 75/16 plus 8 is 203/16. Over 16 x squared. So now it says find the range of values of x for which this expansion is valid. So for our first one that we did, so this one here, you want to look at it when you've taken out the factor. So it's going to be the modulus of 5 over 2x is less than 1. And that's actually in your formula booklet. Let me just show you. So here it says the modulus of x is less than 1. So whatever this is here, it's the modulus of that is less than 1. So for us, it's 5 over 2. So the modulus of 5 over 2x is less than 1. So what we can do is divide both sides by 5 over 2, and that gives us the modulus of x is less than 2 over 5. So that was for our first binomial expansion. For the second one, that was this one over here. It's going to be the modulus of 2x. Don't worry about the negative, because if you're taking the modulus, it doesn't matter. Negative, positive, it's going to cancel out anyway. So the modulus of 2x is less than 1. So that means the modulus of x is less than a half. So you might be able to see the answer straight away, but don't worry if you can't. Have a think about a number line. So if we have 0 here and we have 1 here, this would be a half. 2 over 5 would be about here. So x is less than 2 over 5, so that's these values. And x is less than a half. So what satisfies both expansions? So it must be from here downwards. So that means that the overall, what are we calling it? The range of values for which the expansion is valid is going to be this one here. So it's the modulus of x is less than 2 over 5, because that's the more restricting one. So you want to go with which one is more restricting. Okay? So the examiner report says around 28% of candidates failed to score any marks here at all, which was very surprising. There were, however, many well-formed and accurate solutions by careful candidates. So the maths isn't difficult here, but it's very fiddly. There's a lot of parts. So this is the type of question where you're going to slip up, and then later on all your working is going to be wrong. So you need to be really careful with these questions and make sure if there's any question you're prioritizing to check, it's this one. Because the maths, it's not too tricky, but it's just so many places that you can go wrong. Question 10, and we've got a proof question involving trigonometry. So questions like these, you're either going to get it straight away, or you could spend hours and hours and still never get it. So what I would really recommend is have a go at it. If you think, oh, this is literally going nowhere, I don't know what I'm doing, just stop, go and do another question, and then when you come back to it again, you're going to be thinking about it in a different way. Okay, because it is really like you've got to have a bit of luck with these. So if you start going down the wrong path, it's quite difficult to kind of get back, isn't it? So let's give it a go. What I'm going to do actually first is let's look at the formula booklet. And we've got these trigonometric identities, and it's just going to be helpful for us to have, which ones do we want? These three. Have we got any tan in there? No, we didn't need the tan, but that's fine. Let's put that down there. Right, so we have 1 minus cos 2 theta. That's the same as 1 minus 2 sine squared theta. And if you don't know that off by heart, I do recommend you memorize that one. But let me just quickly show you why. Oh, sorry, not that one. Let's look at this one. So imagine if we've got cos A plus A. So you'd have cos 2A. Then we would have cos squared A minus sine squared A. Okay, from here. We also know that sine squared plus cos squared equals 1. So you can rearrange this to get cos squared equals 1 minus sine squared. So then you'd have 1 minus sine squared A minus another sine squared A. Okay, and that's why we've got 1 minus 2 sine squared A. Plus sine 2 theta. So we're going to be looking at this one here now. So imagine if it's sine A plus A, we would have 2 sine A cos A. Can you see that from this formula? So it's going to be 2 sine theta times cos theta. So over here, I'm going to have on the denominator 1 plus. Now I've got cos 2 theta. So because I want it to cancel out, I'm going to make it in terms of cos this time. So I'm going to have my cos squared theta minus, and then instead of sine squared theta, I'm going to do 1 minus cos squared. Sorry, I shouldn't have written it so close to the edge, which is cos squared minus negative cos squared. So actually we've got 2 cos squared thetas minus 1. So here we have 2 cos squared theta minus 1 plus sine 2 theta. So we can do sine 2 theta. Okay, let's make a little bit more space over here. Now let's multiply this out and hopefully it's going to simplify down to tan. We can only hope. 1 minus 1, so that cancels out. We've got the negative times by this, so that's going to be positive 2 sine squared theta plus 2 sine theta cos theta all over. This 1 is going to cancel out with that negative 1, so that's a good sign. Then we're going to be left with 2 cos squared theta plus sine 2 theta. Did I not change that sine 2 theta? Okay, let's change it now. So that's sine 2 theta. Let's change it up here. We know that that's 2 sine theta cos theta. So here, sine theta cos theta. Now we can do a bit of factorising. So we have 2 sine on the numerator. And in our bracket, we can have sine theta plus cos theta. And on the denominator, 2 cos theta. This is looking good. And then we've got cos theta plus sine theta. So because these two brackets are the same, this means that that's going to cancel with that. The 2's cancel out as well. So we are left with sine theta all over cos theta, and we know that that is tan theta. So we did it. Don't worry if you kind of feel, oh, this is going nowhere. Just as I said, leave it, come back, and then hopefully you'll have some kind of brainwave and you'll be able to do it the second time. Right, for part B, we want to solve tan x equals 3 sine 2x. So let's have a go at that. And to do that, I'm going to write tan in terms of sine and cos. So that is sine x over cos x equals 3 sine 2x. Was it x? Ah, look. Here we've got 2 theta and here we've got 4x. So actually it's tan 2 theta. Oh, sorry, tan 2x. Good job we spotted that, because that could have been an absolute disaster. Okay, tan 2x. That's going to be sine 2x over cos 2x. Multiply both sides by cos 2x and we will get this. Let's make this equal to 0. Factorize it. So I've taken out a factor of sine 2x. And now what this means is sine 2x equals 0 and 1 minus 3 cos 2x equals 0. So if I do sine to the minus 1 of 0, first of all, check your calculator says degrees on the top. Sine to the minus 1 of 0 is 0. So 2x equals 0. Over here, 1 equals 3 cos 2x. Then divide both sides by 3. Then do cos to the minus 1 of a third, and that will give us not a very nice number. 70.5 degrees. It's not the end of the world, but I was just hoping it would have been a little bit nicer. What we're not going to do is divide it all by 2 now. What you need to do is find all of the values within the range and then you need to divide it by 2. It's really good practice to find out all the solutions before you do the calculation, because otherwise, depending on the calculation, it might not be right. Give your answers to one decimal place where appropriate, and it's between 0 and 180. So, where's it gone? If we have 0, and we're going between 0 and 180, but because I'm going to be dividing it by 2, I actually want to go all the way up to 360. Okay, so 360 is here, 0's there, so my other solutions are going to be 180 and 360. Can you see that? Because if this is your solution here at 0, it's also a solution here and here. Now let's do the same with the cosine graph. So this is 360, that's 180, that's 90, so 70 is about there, 70.5. So we're also going to have one more solution over here, and that's going to be 360 minus 70.5, because this distance here is 70.5. So we have got 289.5. Now I'm going to divide all my values by 2. So 0 divided by 2, 0. 180 divided by 2 is 90. 360 divided by 2 is 180, although I just want to check those two to see if it's definitely less than or equal to, or what's going on there. 70.5 is 35.25. And 289.5 divided by 2 is 144.75. Let's just check. X can't be 0 or 180, so it can't be this one, and it can't be that one. So we've got 3 solutions there. So the examiner reports that this question did cause a lot of issues, and quite a lot of students apparently made the same mistake as I nearly did and didn't cross out the 0 or 180. Question 11, and this looks to be a trapezium rule. So we've got a sketch of part of a curve, and it's y equals ln x all squared. The finite region R shown in the diagram is bounded by the curve and the line with equation x equals 2. the x-axis and the line with the equation x equals 4. The table below shows corresponding values of x and y and the values of y given to 4 decimal places. Use the trapezium rule with all the values of y in the table to obtain an estimate for the area of R, giving your answers to 3 significant figures. So the first thing I'm going to do is go back to our formula booklet, because it is in here somewhere. Here it is. Although, if you remember your trapezium rule from primary school or secondary school, you actually won't even need this formula. But we'll put it here anyway, just in case. So here's our equation for the trapezium rule. So we are going to do the area is roughly half the height. So this is the distance between our bars. So if we're going from 2 to 2.5, you can see that it's going to be 0.5, and it has to be the same for every single one. So you can see it's going to be 0.5, which is a half, but I will put it at 0.5. It might be a bit clearer. Times the first and the last added together. This is your y value. Plus 2 lots of all the other values, so the 3 values in the middle. And then put the whole thing into our calculator. And we're going to get, what does it want? 3 significant figures, 2.41. Okay, for part B, use algebraic integration to find the exact area, giving your answer in this form. So it means we can't just whack it all in our calculator at the end, it wants it in exact form. So we're basically integrating this, ln x all squared, between 4 and 2. So let's write that out. Okay, we're going to have to use integration by parts. So let's go to the formula booklet, and we have it here. Just put that on the other page so we can see it clearly. There we are. Right, so we want to call u ln x all squared because we can differentiate that, but we can't integrate it. When we differentiate that, we're going to use the chain rule. So that's going to be 2 ln x, and we decrease the power, so by 1, times by 1 over x, because that's the derivative of ln x. So dv by dx is just going to be 1, because we haven't actually got another term. So when we integrate that, that is going to be x. And it looks like we're probably going to have to do integration by parts twice, which I know is a bit rubbish. U times v, so I'm substituting back in here now, is going to be x multiplied by ln x all squared, minus, and then it's going to be the integral of v times by du by dx. So this does look a little bit confusing. Don't worry, it's going to cancel out quite nicely, because this x is going to cancel out with that x, and that 2 we can actually put outside of the integral. So we're going to be left with x ln x all squared. Don't worry about the limits, I'm going to come back to them at the end. Minus 2, and then the integral of ln x. So integration by parts again. Let's change colour so we don't get confused. U, we're going to call ln x. Du by dx. So if I differentiate that, I get 1 over x. V dv by dx is going to be 1. So when I integrate that, I'm going to get x. Now substitute it back into our formula. We already had our x ln x all squared, so that has to stay there, minus 2 lots of u times v, so that's x ln x, minus the integral of v times du by dx. So x divided by x is just going to be 1. So that's going to be the integral of 1 with respect to x. That's quite nice. So that gives us x times ln x all squared minus 2 lots of x ln x minus 2, and then there's another minus here, so it's going to be positive 2. The integral of 1 is x. And let me put my limits back on. We've got 2 and 4. Substitute 4 in. Two times 4 is 8. Again, 2 times 4 is 8. Substitute 2 in. 2 times 2 is 4. Oh no, not much space. Plus 2 times 2 is 4. Just enough space. Now let's simplify this down. So ln 4, let me just show you this, is the same as ln 2 squared, which is the same as 2 ln 2. So we can rewrite this as 4 lots of 2 and then ln 2 squared, like that. Okay, and I knew to do that because in the question, let me show you, we've got ln 2 here and here. So we want ln 2 all throughout. 8 ln 4, so again, it's going to be 8 times 2 ln 2 plus 8. This is all right because it's already in that form. Oh, let's just be careful about our negatives. So negative times a negative, so that's going to be positive. And then over here, negative times positive 4, so it's going to be negative 4. Now let's simplify further. So we are going to have 4 times 2 squared. 2 times 2 is 4, times 4 is 16. So it's going to be 16, and then the ln 2 is still going to be squared. 8 times 2 is 16. And then this bit, we can't simplify that. That's already simplified nicely for us. Right, let's collect our terms. So we've got ln 2 squared and ln 2 squared. 16 minus 2 is 14. So we've done that term, Minus 16 and plus 4, it's going to be minus 12 ln 2. Plus 8 minus 4 is going to be plus 4. And does that give us the format that they wanted? Yeah, it does. So I'm pretty happy with that answer. So the examiner report said that part A was done quite well, but part B was not done very well because students didn't realise that they had to integrate by parts and instead tried to do some kind of like opposite the chain rule of the log. So it wasn't very successful. So you need to have a look at when you're going to be using the integration by parts and when not to. But chances are, like, they're going to ask it in either Pure 1 or Pure 2. So if you haven't had it in the first paper, chances are it'll come up in the second. But yeah, always think if it's quite a few marks on an integration question, could you be doing integration by parts? Question 12 says, Figure 3 is a graph of the trajectory of a golf ball after the ball has been hit until it first hits the ground, which happens over here. The vertical height, h meters, of the ball above the ground has been plotted against the horizontal distance. So that's a bit unusual because normally this is time. Has been plotted against the horizontal distance, x meters, measured from where the ball was hit. So it's hit over here. The ball is modelled as a particle travelling in a vertical plane above horizontal ground. Given that the ball is hit from a point at the top of a platform of vertical height 3 meters above the ground, so they've given us that on the graph anyway, it reaches its maximum vertical height after travelling a horizontal distance of 90. So this point here is 90, and that's your maximum. The ball is at a vertical height of 27 meters above the ground after travelling a horizontal distance of 120. So somewhere around here, 120, and h is going to be 27. Okay? Given that h is modelled as a quadratic function, find h in terms of x, and it's 5 marks. So it's probably going to be a little bit fiddly. We have got 2 coordinates actually, haven't we? Because we've also got 0, 3. And we also know that when, I nearly put dy, when dh by dx equals 0, so when our gradient is 0, x is going to be 90. So let's have a go. Right, so we know that h is going to be ax squared plus bx plus c, because that's the equation of a quadratic graph. We also have our coordinates. So we had 0, 3, and we had 120, 27. Was that right? Let's double check. Yeah, and we'll see if we need this later on. Let's do this for now. So when x is 0, h is going to be 3. Oh, that's quite nice, because it's going to be 0 plus c. So c must be 3. So we already know that h equals ax squared plus bx plus 3. Now let's try substituting in this one. So 27 equals a times 120 squared plus b times 120 plus 3. And yeah, we've got 3 unknowns, so we do need like 3 pieces of information, because even doing this, because we've got a and b to find, we're not going to be able to do it. So we're going to have to use our maximum turning point as well, unfortunately, but that's fine. 27 minus 3 is 24. 120 squared is 14,400 plus 120b. Now, can I simplify that? Divide by 24? Yes, I can. So I can divide everything by 24. We don't have to do this, but it just means that the numbers are going to be a bit smaller. Plus 5b. Okay, so I've just divided all of these terms by 24, which we're allowed to do because it's an equation. If it was just an expression, then we couldn't do that. Right, so we've used this piece of information and we've used this one. Now we want to use dh by dx equals 0 at x equals 90. Double check, was it 90? Yes. So let's differentiate. We want to try and get an equation with a and b in, and then we can use simultaneous equations. So if h equals this, then dh by dx is going to be 2ax plus b. Okay, that's it. And that equals to 0 when x equals 90. So let's substitute that in actually. 2 times a times 90 plus b equals 0. 2 times 90 is 180. So 180a plus b equals 0. So we have got one equation here, second equation here. Now we're going to use our simultaneous equations. Do we want to do elimination or do we want to substitute one in? It's up to you, really. I think I'm going to substitute in because, yeah, I think that would just be easier. So I'm going to put b equals minus 180a. So I'm going to substitute this into here. So 1 equals 600a plus 5 lots of minus 180a. Let's simplify this. 5 times 180 is 900. 600a, take away 900a, so we've got minus 300a. So a must equal minus 1 over 300 because I do divide by negative 300 on both sides. So I'm left with a equals minus 1 over 300. Then substitute it into your easiest one. So for me, it's going to be this one. Like, don't substitute it back into like this one when this one's really nicely simplified. Then b equals minus 180 times a, which is minus 1 over 300. Put that in my calculator. And I've got 3 over 5. So we've got A, we've got B, we've got C somewhere up here. So now we need to make sure we actually do what the question says, which is find h in terms of x. So all we need to do is write h equals a x squared plus b x plus c, which was 3. So this is our final answer. Part B says, hence find, according to the model, the maximum vertical height of the ball above the ground. So we're finding this point here, which is going to be quite easy because we know that x is going to be 90. So we just need to substitute in, and that will give us our h. So when x equals 90, h is going to equal minus 1 over 300 times 90 squared plus 3/5 times 90 plus 3. Put that all into our calculator. Is 30. 30 meters, does that sound about right to hit a ball? Probably a golf ball. Right, let's have a go at the next part of B. The horizontal distance travelled by the ball from when it was hit to when it first hits the ground, giving your answer to the nearest meter. So we're basically from when it was hit to when it first hits the ground. So we just want to find this coordinate here. So that's going to be when h equals 0. But because this is a quadratic, if I continue this graph, can you see how I'm also going to get a solution there? So I'm expecting to get 2 x values. One's going to be negative, one's going to be positive, and then we're just going to take the positive. So h equals 0. And we just want to go straight for the quadratic formula here because there's no point wasting time rearranging. Let's just go for it. So x is going to equal minus b. Well, it's already minus, so it's going to be positive. Plus or minus the square root of b squared. Again, that will go to positive, but anyway, put it in bracket. Minus 4 times a times c all over 2 times a. Now, if you've got the ClassWiz calculator, you can actually just use your equations and functions and put that straight in. So, and I have got x as 184 point, what did it ask for? To the nearest meter. So actually it's 185. Let me just change that. 185 meters. And my other solution is x equals minus 4.8, which would have been minus 5. But that one obviously can't be the case because we can't have a negative distance. So this is our answer. Done. Next part. The possible effects of wind or air resistance are two limitations of the model. Give one other limitation of the model. So there's a few different things you could do here. Spin of the ball is quite a good one. You could also say the ball has been measured as a particle. You could also say that the ground wouldn't be completely flat, so that could cause issues. So like if the end where the ball lands is actually higher than ground level, that would change things. Anything like that will do. So the examiner report says a wide range of comments were quoted for part C. Some of those did not gain the mark B1 because many of them focused on what happened to the ball after it hit the ground. So it didn't really affect the model that we've got. Question 13, we've got 3 marks, which is quite nice for this part of the paper. We've got parametric equations in x and y. Show all points on C satisfy this. So we're basically going from a parametric equations to a Cartesian equation. So what we're going to need to do is find t in terms of x and then substitute in for here. So let's give that a go. So if I multiply both sides of this equation by t squared plus 1, I will get this. Multiply this out. Then I want all my t terms on the left-hand side and anything not in terms of t on the right-hand side, so that I can then factorize. Can you see what I've done there? Then divide both sides of the equation by x minus 1. There we go. Now, there's no point square rooting this because over here we've got t squared. So what we can do instead is find y squared, because there's a t on the numerator, which then we're going to have a square root. So instead of doing that, let's just square both sides of this equation. That's going to give us this. So I'll write it out in full for you. So 4 squared is 16, t squared. And then let's not multiply that out. So it might work out quite nice when we substitute in. Fingers crossed, it might not. Okay, y squared equals 16 multiplied by t squared. So t squared is 5 minus x over x minus 1. All over t squared, which is 5 minus x over x minus 1 plus 1 all squared. And we want to change this. This is a bit messy, this denominator. But what we can do is write 1. Let me show you. Let me just write this out again. So I'm going to rewrite 1. So it's going to be x minus 1 over x minus 1. Let me show you. Okay, because x minus 1 divided by x minus 1 is 1. So we're allowed to do that. Then this is going to simplify quite nicely. So y squared equals so now we put the whole thing, the whole of the denominator over x minus 1. And our numerator, we're going to have 5 minus x plus x minus 4. Minus 1, which 5 minus 1 is 4. I was getting ahead of myself there. And that's going to be all squared. Okay, because the x is cancelled out. 5 minus 1, 4. Then what I'm going to do is I'm going to multiply well, actually, before I do that, let me write this out again for you. 5 minus x over x minus 1. I'm going to square this. So that's going to be 16 over x minus 1 squared. So when you have got a fraction on the denominator of a fraction, that's the same as multiplying by this x minus 1 squared. So that's going to simplify hopefully quite nicely. Y equals, we're going to have 16 times. Let me write this out so you can see what's going on. So it is a little bit fiddly. All squared. And actually, this is going to be all over 16, which that's going to be quite nice as well. Look, cancel, cancel. Oh, this is amazing. Cancel, cancel. And we have got 5 minus x multiplied by x minus 1, which is not what they wanted. They wanted this. Okay, so we're not done yet. Oh, it's actually quite a lot for 3 marks, isn't it? We are going to multiply that out. 5 times x. 5 times negative 1. Minus x times x. Minus x times negative 1. Simplify this. We have got minus x squared. 6x minus 5. So we want to make sure that on the right-hand side of the equation, we've got 4. Everything else we want to be on the left-hand side. So y squared. Let's add x squared to both sides. Let's take away 6x from both sides. And then to get from minus 5 to 4, I'm going to have to add 9 to both sides. Then y squared, we want that to stay like that. This we can factorise, and actually this is the difference of 2 squares. No, it's not, sorry. It's just going to be x minus 3 squared, isn't it? Yeah, because x minus 3 times x minus 3 is x squared minus 6x plus 9. Yeah, it is. It's great. And that's what the question was, so we've done it. Equals 4, double check. Yeah, perfect, done. So the examiner report says a solution gaining all 3 marks was relatively rare to see, and there were many very poor demonstrations of algebraic manipulation seen. So that means overall people did pretty rubbish on this one. Question 14 is a differentiation question, but they wouldn't be so kind to make it too easy this later on in the paper, would they? So we have y equals x minus 4 over 2 plus the square root of x. It's probably worth our time just writing that out again, and instead of the square root of x, write x to the power of a half. Then let's go to our formula booklet. And we have got over here the equation for differentiating fractions. So let's put that up there. That's going to help us. And let's give this a go. So dy by dx. So the numerator is f of x and the denominator is g of x. We want to do the differential of the numerator. Oh, actually, that's a minus. Just be careful. That could have meant the whole question was wrong. Differentiate this numerator is just going to give us 1 times the denominator. Put it in a bracket so we know it's the whole thing is times. Minus the numerator times the denominator differentiated. So that's going to be, the constant's going to cancel out. It's going to be a half x to the power of negative a half. Okay, can you see that? Because you times by the power, reduce the power by 1. And that's going to be all over the denominator squared. Like that. Right, let's multiply some things out. This first bit's quite easy. Minus. So if we do minus x times by a half x to the power of negative a half, that's going to be minus a half. This is to the power of 1. That's to the power of negative a half. And remember, when you multiply them and they got the same base, you add the powers. So 1 add negative a half is going to be a half. Okay? Now multiply it by negative 4, although just be careful because we've got negative times this negative 4, which means positive 4 times by this. And 4 times a half is 2, so we are left with this. I don't know if I want to multiply out this denominator, because if I do that, I have absolutely no chance of cancelling out the numerator. So let's not do that for the time being. The numerator looks really messy, doesn't it? So let's have a go at, we can actually collect these terms. Let's do that first. So 2 plus, we have x to the power of a half minus a half x to the power of a half. So we're going to be left with this. Okay, what I'm going to do is I'm going to multiply this by x to the power of a half over x to the power of a half, because then this is going to cancel out these powers quite nicely. So then we'll be left with 2 times x to the power of a half, and we could change it back to the square roots now, couldn't we? So 2 root x plus, if we've got x to the power of a half times by x to the power of a half, you add the powers, so that makes 1. A half plus a half makes 1, so it's going to be a half x, like that. Here, again, you add the powers, so that actually makes x to the power of 0, which we know is 1, so that's just going to be plus 2. All over, and here as well, we've got to multiply it by x to the power of half. There we go. Now I'm going to multiply it by 2 over 2 to get rid of this half, because I think that's going to work out quite nicely. Let's just put that there. So we're going to have 4 root x plus 4 all over 2 root x multiplied by 2 plus root x all squared, because now I can actually factorize this numerator, and I'm absolutely hoping that one of the brackets is going to be 2 plus root x. So I'm going to put it there because I'm feeling optimistic. So what would we need to times it by to get this? So 2 would need to be multiplied by 2 to get 4. root x would need to be multiplied by root x to get x. And then if I make this positive, it works. Oh, and even better, because look, this is squared. So 2 root x multiplied by 2 plus root x, all squared. This one is going to cancel out with these 2 because it's squared, and we're going to be left with 1 over 2 root x. Let's check the question. Yeah, where a is a constant to be found. So a is 2. The examiner report said that it was not done well by that many candidates. Most solutions seen and used the quotient rule, although incorrect application of the rule often meant that no marks could be awarded, which is so frustrating because the formula is literally in the formula booklet. So make sure when you're practicing these past papers that you're using the formula booklets. The most common errors were subtracting the wrong way around on the numerator, or else adding the 2 expressions on the numerator. Also, differentiation of the square root of x surprisingly caused a few problems as well. Okay, last question. Well done if you're still here. Use proof by exhaustion. Almost couldn't say that then. So we're saying n is less than or equal to 4. So I'm going to do a little table here. So n, I'm going to do 1, 2, 3, 4. So n plus 1 cubed. So here we're going to have 1 plus 1 cubed. Is that greater than 3 to the power of 1? Well, 1 plus 1 is 2. 2 cubed is 8. 8 is less than 3. Greater than 3. Yes, it is. Next one. 2 plus 1 cubed. Is that greater than 3 squared? 2 plus 1 is 3. 3 squared? 3 cubed, is 27. We knew that. 27 is greater than 3 squared, which is 9. Correct. 3 plus 1, all cubed. That's going to be 4 cubed. I didn't write this bit down. 256. Is that greater than 27? Yeah, it is. Next one, 4 plus 1 cubed. Is that greater than 3 to the power of 5? 5? Sorry. Is that greater than 3 to the power of 4? Let's check. 4 plus 1 is 5. 5 cubed is 125. Is that greater than 3 to the power of 4, which is 81? Yeah, it is. So let's put our statement. If, and basically just copy it from here. If n is less than or equal to 4 and n takes all natural numbers, which again, we're just taking it from here, then n plus 1, all cubed, is greater than 3 to the power of n. Done. Aye. 4 marks. Last question. Given that m cubed plus 5 is odd, use proof by contradiction to show, using algebra, that m is even. So, let m be odd. Got a mark for saying that. So, we're going to put m as 2n plus, let's not use n because we did it on the last question. Let's do 2a plus 1. So 2a plus 1 is always going to be odd, because if you times anything by 2, it will always be even. Add 1 makes odd. So let's have a look. 2a plus 1, all cubed, plus 5. That's what we need to work out now. Little bit fiddly. So what I'm going to do is write out 2a plus 1. Then I'm going to write out 2a plus 1 again. And for a third time, plus 5. Right, let's multiply these two brackets and then we'll multiply it by that one. 2a times 2a is 4a squared. 2a times 1, it's got 2a. 1 times 2a is another 2a, so that's going to be 4a. 1 times 1 is 1. And multiply that by 2a plus 1. Right, let's multiply everything by 2a. Multiply everything by 1. And then don't forget we've got plus 5 on the end. Now let's simplify it down. A cubes, so 8 of those. The squared, we've got 8 and 4, so that's 12. Then the a's, we've got this one and this one, which is 6a. Then we've got this and this, which is 6. Right, what are we proving? Given that it's odd, use proof by contradiction to show using algebra that m is even. So the way that I like to show that something's even is I take out a factor of 2. So then we will have this. And because we're multiplying it by 2, it must be even. Then we just need to make a statement. Something like, this is a contradiction. So if, what was it? Check back on the question. n cubed plus 5 is odd. M must be even. There you go. So, weirdly enough, the examiner report says that part 2 was actually done really well, but part A wasn't done very well. So let me show you part A again. So we literally just substituted in every single value, but what some students did was substituted in n for 4, showed that it worked, then substituted n for 5 and showed that it didn't work, and then said, oh, well, we've done it. That's not the way you need to do it. You need to literally do every single value to show that it works. But there won't be like a million values. Like as you could see here, there were just 4. Well done if you made it to the end of this video. If you found this helpful, then please follow me, leave me a comment, let me know how you got on, and really good luck for your exams.